So with these starting materials, they're making this product, and they want us to give a mechanism that explains this, right? Okay, well what's going to be the first thing that happens in this mechanism?
The oxygen combines with the aluminum.
Very good. We know that Lewis acids want to gain electrons. Now it's very important then that we put the charges in, the positive charge on this oxygen and the negative charge on this aluminum. Okay, and then we need to know which of these two carbons the benzene is going to attack. The left-hand or the right-hand carbon.
We know it's the right hand because that's what it says in the answer key.
And we basically need to explain that. Now, there's basically two different cases for three-membered rings. When you're attacking a three-membered ring, you can attack a neutral three-membered ring or a positively charged three-membered ring. In this case, the nucleophile prefers to attack the less hindered carbon. And in this case, it prefers to attack this carbon over here.
We're just supposed to memorize that?
That's right. We actually talked about the reasoning for this a little bit last term, because this came up with bromonium ions as well. So the point here is, in this picture, both of these carbons have carbocation character. In this picture, both of these carbons have carbocation character because the positive charge is spread out over the molecule. But which of these is going to have more carbocation character? This one, because it can stabilize the positive charge better. So in this case, we expect that the positive charge will sometimes be on the oxygen, sometimes on the left-hand carbon, and sometimes on the right-hand carbon. But the positive charge is not going to be on the left-hand carbon very much because that wouldn't be very stabilized. The positive charge would mainly prefer to be on the right-hand carbon because it's more substituted. On the other hand, in this case, there is no carbocation character because there's no positive charge. So now we revert back to steric hindrance. Now this is better because there's less steric hindrance. So if there's no carbocation character argument, you want to attack the place that has less steric hindrance. But if there is a carbocation character type situation, then you want to attack the carbon that's more substituted because it'll be better able to stabilize that positive charge. So it's important to have both of these cases in your notes. If you're attaching a neutral three-membered ring, you attack the less sterically hindered. And with a positive charge, you attack the more sterically hindered. So the benzene here would attach like this. And that explains why, in this case, this carbon ended up attached. The more substituted carbon ended up attached. And then eventually this oxygen is going to protonate. Okay? Okay, so it's good to have these ideas in your notes here. Well, this just brings us back to what we saw before. You can expect to see lots of electrophiles that you might not have seen in lecture attacking the benzene. Okay, good. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. Thank you.